All right, here is part 2, these 3 questions. I made 2 just in case you only were interested in this one. All right, so first thing, when you guys are doing these, you're going to have to remember your algebra skills, which for some of you will be more difficult than for others. So when you're doing this, you want to be looking for how can I get the x's on one side if possible. So in this example A, since we have an x under the square root sign and it's attached with a -3 and you have a 2x on the other side, there's no way just to bring the x's over. So we're going to have to get rid of this 3 by adding 3 to both sides. So this is not 5x, it's 2x plus 3 on the left, and then square root of the 28x plus 29. That's going to allow us to nicely be able to square both sides in this step right here. So when we square both sides, you're going to have to make sure you square properly. So in the left-hand side, it's not 4x squared plus 9. You guys, for those of you that like your area method, you got a 2x plus 3 and a 2x plus 3. So you have your 4x squared, your 6x, and your 9. And then you're going to add your diagonals together. All right, for those of you that don't use the area method, you can square the first term. That's, oh, let me change colors here. That's 4x squared. Square the last term, that's 9. Multiply the 2 terms together, that's 6x. Doubled is 12x. So notice, if you do it that way, or if you do it this way, when you add the 6x and 6x, there's your 12x. You get the same answer. Now this side, since on the right hand side everything is under your square root and you're squaring that, basically the square and the square root cancel each other out. So you get 28x plus 29. So now we can move everything over to one side and combine your like terms. So we can leave the 4x squared because there's no other x squared term. We bring over the -28x, or the 28x over, it becomes negative, and then we'll combine it with the 12x. Sorry, my screen keeps flipping around. And then that's going to give us 16x. So I just minus 28x. But I guess that would give us a negative, not a positive. And then if I move the 29 over, I'm going to end up with a -20. So I have 4x squared minus 16x minus 20 equals 0. You could factor out a 4 because 4, 16, and 20 are all divisible by 4. So that'll make factoring a little nicer to do. So if we factor out a 4, we get an x squared minus 4x minus 20, or minus 5 rather, because 20 divided by 4 is 5. And then we need to factor what's in parentheses. So the 4 isn't going to play any role in solving. If we were asked to factor and show the factors, then yes, but because we're asked to find where it crosses the x-axis, if we were to graph it, we're solving. We just need to factor the x squared minus 4x minus 5. So two numbers that multiply to -5 and add to 4. So however you guys end up factoring, whatever your preferred method is, I need two numbers that multiply to -5 and add to -4. So that's going to be -5 and +1. -5, +1. These two multiply to -5 and they add up to -4. Or if you cross multiply, 1x minus 5x equals -4x. So set each factor equal to 0 and you have your factors you're solving where it crosses the x-axis. So 5 and -1 would be your two answers. Now generally you need to check and make sure those are actually solutions. So you could graph if it's easier. You could quickly plug them in sometimes. So if I plug in a 5 here, I get a 10. You want to make sure that your answers will actually work and you won't end up with a negative square root, or that two numbers that actually don't end up being the same. So our third example, I believe, will have an extraneous one. So we'll find out in a couple minutes, but here are two answers for question A. Now let's look at a problem like question B. So I got a cube root. I only have one term with an x in it, so that makes it nice. So if I bring over the 8, so I subtract 8 from each side, so that gives me a 4, and I have my cube root of x minus 2 squared. Then I can't square both sides because I don't have a square root. I am going to have to cube both sides to get rid of that cube root. So in this case, be real careful that you're not on autopilot because we square both sides so much. We actually need to cube both sides. So that's going to give you a 64 here. That's going to cancel those out, so you just get the stuff under the cube root symbol. And then you'll have to, now in this case you can do one of two things. You could square root both sides because you don't have anything added or subtracted to the square term, but you're going to have to remember that it's a plus and a minus square root of 64, so, and then you might end up with a decimal, so you got to keep that kind of stuff in mind. So let's just do it the factor way. So remember, square the first term, square the last term, multiply the two together and double it, or you can do the area method with the box. Now we're going to get the constant over, so I'm going to subtract the 64 over with the 4, and I have 0 equals x squared minus 4x minus 60, and then I'm going to have to factor that. So x and x multiply to give you x squared, two numbers that multiply to 60, but when we cross multiply it gives us a negative 4x. So I'm going to go with negative 10 and positive 6. So this positive 6 times negative 10 is negative 60, and if I cross multiply, negative 10x plus 6x gives me a negative 4x. So if I solve this, I get x equals negative 6, x equals positive 10. And again, if I plug those in, double check for extraneous solutions. All right, last one, and the longest problem that we have is C. C takes a bit more work because you have a square root and you have a constant, and there's nowhere to move the constant to make it an easy problem like A. So we're going to have to FOIL with a square root and a constant, which is not going to be pretty, but we can handle it, hopefully. All right, so first things first, since we can't get the x's together, we can't move a constant to make a problem like A, we're just going to have to buckle down and square both sides. Let me zoom in so I can write a little bit easier, maybe. Probably not, but we'll see. All right, so I'm going to square both sides. So this square is going to make the square root cancel out. So this side's easy. It's going to be an x plus 1. No big deal. Next, not so easy. So we can still apply the same process. You can either use the area method or my method, which is square the first term. 1 squared is 1. Square the last term, which is just going to be the stuff under the square root sign. I'm going to leave a big space. And then multiply these two together, which is just going to be square root of x minus 12, and double it. So it's going to be 2 of those. 2 times the square root of 2x minus 12. Okay, so squared the first term was the 1. Square the last term is just the 2x minus 12 without the square root sign. Multiplying these two terms together, since this is a 1, it's 1 times that, and doubled would be 2 times that. All right, so we had nice numbers to play with there. Let's do everything that we can to simplify this. Chances are we're probably going to have to square both sides again, but let's see what happens. So if I bring this 1 and this x over, so minus 1, and then I'm going to just do it in one step. Hopefully you guys can follow along. Minus x, just to get a 0 here. So these are gone. Then we have our 2 square root of 2x minus 12. And then we have a 2x minus a 1x, which is a 1x. And then we have minus 12. Right, that wasn't so bad. All right, so the issue here is we have a constant, like without a square root, with an x, and we have an x under a square root. So now we have a situation kind of like we had with A example. So if you look back at A, we moved that 3 over to be with the 2x. We're going to do the same thing here. We're going to move this term over to the other side so that we can square both sides. And at this point, it is a problem just like A was. We just had to do some extra stuff to get there. So let's move this stuff back. And I'm getting rid of the parentheses. You don't need to, or you can keep them. It doesn't matter. I'm just getting rid of them just so I don't have to write them. So I'm moving that over. There's that equal line. So we're going to have this problem. Negative 2 square root 2x minus 12 equals 1x minus 12. Now we're going to square both sides again like we did in problem A. Sorry, my handwriting is so messy. It's not easy to write with one of these pens. It kind of like drags. Maybe I can find a way to make it not, but not right now. All right, so if we square this, you're going to have this number squared and this part squared. So this is going to be a 4, a positive 4. This is going to get rid of the square root. So this is just going to be 2x minus 12. Okay. Make sure that you get rid of that negative because it's negative 2 times negative 2. And then if we, again, square the first term, square the last term, multiply these two terms together, that's negative 12x, doubled is negative 24x. And then we can distribute this 4, so we get 8x minus 48 equals 1x squared minus 24x plus 144. Get everything and combine like terms. Get everything on one side, combine like terms. So if we move the 8x over, we can combine it with the negative 24x. And if we move the 48 over, we can combine it with the 144. So we get 0 on the left, and we get negative 32, and we get a 192. And then we can factor that. So two numbers that multiply to x squared would be x and x. So 1x, 1x. Two numbers that multiply to 192. When you cross multiply, they add up to be negative 32x. 8 and 24 plus 8 plus 24. So 24 and 8 is 32. Oh, I'd have to make them negative. So now they multiply to give us positive 192, and then when we cross multiply, negative 24x minus 8x is negative 32x, so that works out. So right now our answer is x equals positive 8 and x equals positive 24. However, if you plug in 24 into the original problem, so let's go up to this original problem. If we plug in 24 here, we get square root of 25, and if we plug in 24 here, we get 48 minus 12, 48, which is not, plus 1, which these two will not match. So this one right here is extraneous. So that's why you gotta check to see. So that one does not work. All right, there's that. Again, there's an IXL assignment that you can practice doing these. And then make sure you ask me any questions. If I get a bunch of people asking me questions on certain things, then I can do some kind of Google meeting or something like that to answer questions. All right, good luck.